structures of complexes based on valence bond theory. Structure of different complexes based on valence bond theory. So we have to see one or more complexes, that is, and we have to see the structural features of the complexes. First complex that we have to see is nickel tetracarbonyl. Structure of the complexes, that means what we have to see? We have to see the electronic configuration in ground state, electronic configuration in hybridized state, hybridization of the central metal ion, geometry of the complex, magnetic behavior of the complex. So structural feature includes all these properties. So first of all, let us see about nickel tetracarbonyl. What is this nickel tetracarbonyl? This nickel has atomic number 28. So its electronic configuration is argon 3d8 and 4s2. It may be written as 3d8, that 1, 2, 3, 4, and this is 4s2. This is 3d and 4s. So number of electrons are 1, 2, 3, 4, 5, 6, 7, 8. Pairing is there. And 4s contains 2 electrons. Now, since this nickel is in ground state, since this CO is strong field ligand, it causes pairing of electrons. These 2 electrons from 4s orbital are shifted to 3d orbital and causes pairing of electrons, and hence then electronic configuration becomes electronic configuration 1, 2, 3, 4, 5, 6, 7, 8, and these 2 electrons causes pairing like this 3d, and this 4s and 4p undergoes hybridization, that is sp3 hybridization, and causes hybridized orbitals. So the electronic configuration of the complex NiCO4 becomes, this is 3d and this is sp3 hybridized orbitals. Four sp3 hybridized orbitals. These 4 sp3 hybridized 4 CO groups donates 4 electron pairs to this sp3 hybridized orbitals and forms a complex like this, forms a coordinate bond. This is electronic configuration in the hybridized state, or when complex is formed. Now, hybridization, what we have to see is that hybridization of this central metal ion is sp3. So geometry is tetrahedral. And what is magnetic behavior? The complex is diamagnetic in nature. Magnetic property, it is a diamagnetic in nature because the magnetic moment is 0 and it do not have any unpaired electron. It cannot have any unpaired electron. Therefore, this magnetic moment is 0 and hence this complex is diamagnetic in nature. So these are the properties. Central metal atom has hybridization sp3. It has a geometry tetrahedral. It is diamagnetic in nature and its magnetic moment is 0. So this is about nickel tetracarbonyl. Then next complex that we have to see is NiCl4 2 minus. NiCl4 2 minus. We have to see the structure of this complex. In this case, nickel is in +2 oxidation state. So it has electronic configuration 3d8. That is, this is a D8 case, and its electronic configuration may be written as (3d), 4s, and 4p. So electronic configuration is 1, 2, 3, 4, 5, 6, 7, 8. Since it has its coordination number is 4, this nickel makes available 4 vacant orbitals for the hybridization. Since this Cl is weak field ligand, the pairing of electron cannot take place. So the hybridization is sp3 hybridization, like this. sp3 hybridization. And when this Cl donates the electron, it forms sp3 hybridization, and when it donates the electron to the hybridized orbitals of the nickel, the electronic configuration becomes, electronic configuration of NiCl4 2 minus becomes like this. These are sp3 hybridized orbitals. 4 sp3 hybridized, because 4 sp3 hybridized orbitals are available. Vacant orbitals are available to accommodate the electrons which are donated by these Cl minus ions. This Cl donates 8 electron, and this is the electronic configuration when complex is formed or in hybridized state. Now we have to see the properties. Since the hybridization is sp3, geometry of the complex is tetrahedral. Geometry of the complex is tetrahedral. Then magnetic behavior. Magnetic behavior, it is a paramagnetic with respect to 2 electrons, because it has 2 unpaired electrons. It has 2 unpaired electrons, and it is paramagnetic with respect to 2 electrons. Hence, the magnetic moment corresponds to 2 unpaired electrons. It is 2.8 or 7.9, like this. So it is paramagnetic in nature. So this is the structure of NiCl4 2 minus. Then we have to see one more compound, that NiCN4 2 minus, third one. NiCN4 2 minus. In this case also, nickel has +2 oxidation state, and its electronic state, electronic configuration of the nickel +2 ion is 3d8, like this. But this Cn is a strong field ligand, and if the ligand is strong field, it causes pairing of the electrons. So in this case, pairing of electron takes place, and the electronic configuration becomes, it makes this vacant d orbital, this 4s, and it is a 4p. Now these 1d, 1s, and 2p undergoes dsp2 hybridization, and the electronic configuration of the complex becomes electronic configuration of the complex, that is NiCN4 2 minus. It may be written as, this is 3D, only 4 orbitals are there, which are completely filled. And these are the 4 orbitals having hybridization DsP2. 1D, this is 3D, this is 4s, and this is 4p. 1D, 1s, and 2p orbitals undergo hybridization and forms DsP2 hybridization, and this one is 4p orbital. So the electronic configuration, this Cn minus donates the electron pair to the vacant orbitals of the nickel and forms a coordinate bond, 4 coordinate bonds, and this is the electronic configuration of this complex in hybridized state or when the complex is formed. Now, since the hybridization is DsP2, its geometry is square planar. Geometry is square planar. And what about magnetic behavior? Its magnetic behavior is diamagnetic in nature. Why it is diamagnetic? Because it do not contain any unpaired electrons, hence it is a diamagnetic in nature. So this is the structure of NiCN4 2 minus. The next structure that we have to see, one more structure. Now let us see, these are the complexes which has coordination number 4. Now let us see some complexes which has coordination number 6. Since the coordination number is 6, the geometry of the complexes is octahedral. So let us see some complexes having octahedral geometry or coordination number 6. Let us see first of all about CO NH36 3 plus. This is CO3 plus. Remember one thing. CO has atomic number 26. CO3 plus, there are 26 minus 3, there are 23 electrons, and hence it is a D5 case. It is D5 case. So electronic configuration of this is 5 electrons are involved in this. So it is a D6 case, not D5. It is a D6 case. Atomic number is 27. Minus 3 electrons, it becomes 24. Hence it is a D6 case. And there are 6 electrons in 3D orbitals. Now, this NH3 is a strong field ligand. So this causes pairing of electron and makes these 2 d orbitals vacant to accommodate the electrons which are donated by the NH3 or for hybridization. It makes available these 2 orbitals for hybridization, and hence the electronic configuration may be written as these 3d orbitals which causes pairing of electrons. This is 3d. These 2 vacant d orbitals, 4s and 4p. So the hybridization is D2sp3 like this. These vacant 2d orbitals, 1 4s orbital and 3p orbital undergoes hybridization, and the electronic configuration in hybridized state or the complex becomes electronic configuration of CO NH36 3 plus, can be written as, this is 3D, It is D2sp3. D2sp3. These 6 orbitals are there which are filled by donation of electrons from this ammonia and forms a such type of complex. This ammonia forms a coordinate bond with this central metal ion cobalt, and the electronic configuration of this is like this. Now, since the hybridization is D2sp3, its geometry is octahedral. Since there are no unpaired electrons, its magnetic behavior is diamagnetic. Therefore, magnetic moment is 0. Since 3d orbitals, that is inner d orbitals, are involved in the hybridization, it is known as inner orbital complex. Since inner d orbitals are involved in the hybridization, it is known as inner orbital complex. This inner orbital complex is also known as low spin complex, or spin paired complex. Low spin or spin paired complex is there. So this is inner orbital complex or low spin or spin paired complex. So this CONS36 is also known as inner orbital complex, low spin or spin paired. This is the structure of CONS36. So main important features of this structure are hybridization of the central metal ion is D2sp3. Then since hybridization is D2sp3, it has octahedral geometry. It do not contain any unpaired electrons, hence it is a diamagnetic. Since inner d orbitals are involved in the hybridization, it is inner orbital complex or low spin. There is no spin, spin are balanced, hence it is a low spin or spin paired electron complex. It is also known as low spin or spin paired complex. So this is about the CONS36. This is the structure of CONS36. One more complex that we have to see is COF6. COF6 3 minus. Now in this case also, this CO has oxidation state +3, number of electrons are 24, and it is a D6 case. So it has, this is the structure, this is orbital picture of this CO +3. It has 4 unpaired electrons. Now in this case, these 4 unpaired electrons remains as it is, and then S, P and D orbitals. In this case, since this F is a weak field ligand, so in this case, pairing of electrons cannot take place. They remains unpaired. So for hybridization, remember one thing, coordination number is 6. Therefore, that CO should make 6 vacant orbitals to accommodate the electrons which are donated by F. Hence, in hybridization, the orbitals involved are 4s, 4p and 4d, like this. So the electronic configuration of this COF6 becomes, this electronic configuration of COF6, 3 minus, becomes, this is 3D, which contains 4 unpaired electrons and 1 orbital having paired electrons. These 4 sp3 and 2d orbitals undergo hybridization, that is sp3d2. And these are the vacant 3,4d orbitals. Now hybridization is sp3d2. Hybridization is sp3d2. Now since the hybridization is sp3d2, the geometry of the complex is octahedral. Geometry of the complex is octahedral. Since it contains 4 unpaired electrons, it is paramagnetic in nature. So magnetic behavior of the complex is paramagnetic. Because it contains 4 unpaired electrons, it is a paramagnetic in nature. Then in this case, outer d